Okay, good afternoon. Today we're going to talk about graphing quadratic curves or quadratic functions. We're talking about graphs that have the shapes like this or this. So they are usually called quadratic curves or quadratic functions, or more commonly known as parabolas or parabola. Right? Before we go into graphing these curves, let's recall some previous knowledge from linear graph. Term. A term can be a number, a term can be a letter, or a combination of both. So this is seen as one term, or a combination is seen as one term, or in the form of product or quotient. So most science students misinterpret and call this two term, but this is one term. Once it's in the form of quotient, division, or product, it's seen as one term. And this number is also called constant. Remember, constant in algebra. So terms, because we need to recall this from linear graph. We're going to the quadratic curves or the parabolas. Another concept, coefficient. Coefficient from previous class is just the constant in front of the variable, the constant before the variable, whether it be positive or negative. In this case, it's positive 7. So the coefficient is usually the constant in front of the variable. Observe. With this term, this x term, the variable, the coefficient here is 1. Again, with this term, the coefficient is 1. Because sometimes students overlook and forget that 1 is seen here as a coefficient. So we must remember that, right? It can be positive or it can be negative, all right? Coefficient is a constant in front of the variable. We should also remember our skills of substitution, because if we are using table values to graph these functions or parabolas, we need the skills of substitution that we learned earlier when solving equation and expressions algebraically. So we must recall our skills of substitution and recall seeing everything as all terms as negative and positive. Another concept, scales. Scales. Most times we are given suitable scales to graph our parabolas or our quadratic curves, right? We are given suitable scales on the x and y axis. Okay, so let's develop an understanding of scales. So on your Cartesian plane, we have might have our x-axis on our y-axis, and we are given suitable scales at time. For example, if you are given a scale of 1 centimeter representing 1 unit, from earlier class we recall that the distance between the brighter lines on the grid paper measures 1 centimeter. So what they are saying, from the origin going to your right or left, 1 centimeter represents 1 unit, meaning that 1 centimeter space we are going to count by series of 1. So we start here, 1, 2, 3, 4, positive 5, and to your left now, negative 1, negative 2, negative. So the space or distance we're going to count by 1, series of 1, but the distance space is going to be 1 centimeter. Let's look at another scale. Suppose we're given a scale of 1 centimeter represent 5 units. They are saying that 1 centimeter from the origin going to your left or right or up or down on the y-axis or f of x. So every 1 centimeter we are going to count in series of 5. So from here, the first 1 centimeter, the first brightest line, we say 5. Then to the next bright line, 10, positive 15, positive 20, positive 25, and so on. I will say positive, negative 5, negative 10, negative 15, and so on to your left. And up from the origin, we say on the y-axis, every 1 centimeter, 5, 10, 15, 20, and downwards, where the negative values are found, is negative 5, negative 10, negative 15, and so on. So 1 centimeter representing 5 units means every 1 centimeter apart we are counting up by 5 or down by 5. Let's look at another scale. Suppose we are given a scale of 2 centimeter representing 1 unit. They are saying that 2 centimeter from the origin, 1 centimeter, 2 centimeter, that's where we're going to start count from. So between the units, we're going to have 2 centimeter spacing. So here would be our first one. We're going to count by 1. We're counting by a series of 1 because 2 centimeter represents 1 unit. So every 2 centimeter, that's where we're going to put a value. So we'll have positive 1 here, next 2 centimeter, positive 2, positive 3, and so on. And to your left now, you'd have negative 1, skip 2 centimeter, negative 2, skip 2 centimeter, negative 3. So 2 centimeters. So when they say 2 to 1, we mean every 2 space we're going to count by 1. If they say 1 to 1, every 1 space we're counting by a series of 1. Okay, if they say 1 to 5, every 1 space we're going to count by a series of 5 to your left or right, up or down, positive or negative. Alright? Another concept, coordinates. Coordinates are set of values, ordered pairs, x and y. We learned that from linear graph. So we have a coordinate 6, 4. The first value represents the x, second value represents the y. So coordinates, we must remember that we need x and y in order to plot our graph. We need our coordinates. Alright? So set of coordinates give us a point. Intercepts. Intercepts here in graph, whether linear or the quadratic, we're talking about where the graph crosses the x-axis or the y-axis. For example, on this example here, this graph here cross the y-axis at positive 5. So if they ask you for the y-intercept, is where on the y, which value does the graph crosses on the y-axis? And here it's the answer or the solution will be positive 5. If they ask you for the x-intercept, it's which number on the x-axis the graph crosses. And in this case, the graph crosses at negative 3. So the intercept, the x-intercept would be negative 3 and the y-intercept. But for quadratic curves, instead of intercepts, they will use words like roots. They will still ask for y-intercepts, but if they interchange and say x-intercept, the word that we'll use for x-intercept might be roots. Okay. Alright, let's look at a question. Graph the function f of x equal x squared minus 3x minus 3 using a scale of 2 centimeters to represent 1 unit on the x-axis and 1 centimeter represent 1 unit on the y-axis for minus 2 is less than or equal to x is less than or equal to 5. Let's understand concept in the questions. We know that we're not going to graph a linear because of this function here. We observe it's a quadratic from what we have done so far in solving quadratic using the formula and factorizing method. So it's a quadratic function. We'll know that it's a function from the table values, or at the end we can do a vertical line test to tell if it's a function. Okay? But when we observe this part of it, the equation here, we know it's quadratic because of this power here. So when we say that, we must understand our terms. All right? Here's a blown up version of the question. The function x squared minus 3x minus 3. In this equation here, or this expression here, we observe that we have 3 terms. 1, x squared term, 2, negative 3x here and negative 3. From here, we can observe that our y-intercept is going to be negative 3. So this quadratic curve or the parabola is going to cross the y-axis at negative 3. The coefficient here of the x squared is positive 1, which is a from what we learned from the quadratic formula. And from here, we can tell what type of graph we are going to have, if it's a maximum or minimum graph. Because when a is positive or greater than 0, we're going to have a minimum graph, and the graph is shaped like this. We can see that the coefficient is positive here, and it's 1. So when it's positive or greater than 0, then we know that we're going to have a minimum graph, meaning the graph going to have a lowest point. So the legs of the graph will push towards the positive side of the y-axis. Another example, when the coefficient of the x squared term is negative, it's going to be reversed. From right here, we can tell that we're going to have a maximum graph. When a is less than 0, meaning it's a negative value, then we know that we're going to have a maximum, meaning the legs of the graph are going to push towards the negative side of the y-axis, and the turning point, the curve of the graph, will turn up this way. So we'll have a maximum point. Okay? Now back to the question. Now looking at this, go on a version. We are given a scale of 2 centimeters represent 1 units on the x-axis. So we can be given different scales on both axes. So they're saying on the x-axis, for every 2 centimeters, we're going to count in series of 1. So every 2 space, we're going to count 1, then positive 2, positive 3, from the origin going to your right, and every 2 space, going to your left, you skip 2 space, negative 1, negative 2, going to your left. However, on the x-axis, the scale is represented by 1 centimeter to 1 unit. So every 1 space or 1 centimeter, we're counting by a series of 1 going up to the positive side or down to the negative side of the y-axis. For negative 2 less than or equal to x less than equal to 5. This information here is giving you the domain values that you are working with, because in graph x is the independent variable and y depends on it. So what values if the domains are not given, you can choose your domain set. But in this case, they're giving you a domain set. They are working from negative 5 to 5, where the graphs going to stop on your grid paper when you draw your parabola. So the domain sets are given. All right. Okay. Now, so recall, it's important to recognize that there are 3 terms, because we're going to separate in the 3 terms when you're doing the table values. So we're doing the table values method to graph this parabola. So let's go to the table values. So the domain set that they give us is negative 2 to 5. So to create the table for f of x, the function x squared minus 3x minus 3, we're working with domain set. So we're going to start from negative 2, negative 1, 0, 1, 2, 3, 4, 5. So that's where, and that's why this is important, the domain set. Okay? Vertically, to know how many boxes we need depends on our expression here. There's 3 expressions, there's 3 terms, so we're going to separate each of them to fill each box. So the x squared term is going to come here, negative 3x is going to come here, and negative 3 come here. And then f of x, which is the same as y, goes in the final box. So this is where I said that your skills of substitution will be necessary to fill out these boxes to complete the table values. So what we are saying that to find what should go here, we're going to use this expression, this term here, x squared. So we write the expression x squared and we just follow the expression. We can do it manually and then we go back and check our calculator for our reinforcement. So x squared, what is x? In this case, x, the value for x is negative 2. So it's negative 2 square. And when we square negative 2, we are going to get 4. And we do the same for this box. In this case, x is negative 1. So x squared, write the expression, then we substitute. X is what? Negative 1. Then we square it. And the result is going to be 1. And we do the same procedures across. Right, so when we do all our calculations across, we're going to get the values that should plug inside the boxes here. So my advice to you is to do it manually and use a calculator for reinforcement. So we're completing the table values. Now to fill this box, we're going to use this expression. So this expression here is negative 3x. So it's negative 3 times whatever the value of x is. And in this case, x is negative 2. Sine times sine, we deal with our sine. It's going to be a positive 6. So we know that positive 6 should go here. Now we carry out the same computation. We're using the same expression, 3x, negative 3x. So it's negative 3 times whatever is x. And the value for x here is minus 1. And we deal with our sign first. We're going to get our sign. So we're going to know we're going to get price multiplication. We're going to get positive 3. How we fill in our values. And we do the same computation across. Until we complete all the values. The constant, which is normally in the expression, we normally carry it across we learn from linear graphs. Since it's going to be the y from already we know it's the y-intercept, so we just fill out all the boxes across. That it will never change because it's the y-intercept. And the final stage is that we are going to add all these 3 columns. We're going to add these 3 values to get the y, f of x. So we had 4 plus 6, 10, plus minus 3, which will give us a result of 7. So the skills of integers comes back in to complete the table. The reason is that because we need coordinates, ordered pair, x and y, to plot the graph. So we had these 3 columns. So 1 plus 3, 4, plus negative 3 will give me 1. 0 plus 0 plus negative 3 will give me negative 3. So remember, after we fill out our columns, we had these columns between the x and the y to get y. And the reason why all this negative 3 goes right across because it's a y-intercept, and remember we learned it from the linear graph. So 1 plus minus 3 plus minus 3 give us negative 5. 4 plus negative 6 plus negative 3 give us again negative 5, and so on and so on. And we have completed our table values. Now we have completed our table values. We have the coordinates. So the first coordinate here would be minus 2, 7. minus 2, 7, because we need x and y to graph. The next coordinates would be minus 1, negative 1, and 1. So we pick up the x value and the f of x, which is the y value, so we can plot our graph. Right? Okay. Now that we have completed the table value, the table value can tell us a lot of things. These values at the bottom represent the y values on the y-axis. So we recognize that the highest value that we're going to need is 7 on the y-axis. The largest value I need on the x-axis is positive 5 on the positive side and negative 2 on the negative side. So we don't need to fold our graph leaf to the center. The table values can tell you the values that we need, or how to extend, or how far we need to draw our x-axis on our y-axis. Again, the biggest number on the y-axis is 7. Smallest on the x is minus 5. The largest is positive 5. So this can tell us how to draw our graph. Okay? So we have preset our graph. So based on the scales that were given to us, the scale said that 1 centimeter represents 1 unit on the y-axis. So it's 1 to 1 on the y-axis. So every one space we count it by a series of 1. But on the x-axis, 2 centimeter represent 1 unit. 2 centimeter. So from here to here is 2 centimeter. So we start count. So the same distance here, we're going to need the same distance here. That's what the scale said, 2 centimeter to 1. So we're counting every 2 centimeter counted by a series of 1. And remember, on our stable value, the largest value was 5. So we're going up to 5. And on the x-axis, the smallest value was negative 2. So we don't have to go farther than negative 2. So every 2 space, we have negative 1, negative 2. So we have 2 different scales. Now we can plot our graph. So let's go. The first point is minus 2 to 7. So it's negative 2 to positive 7. So we go horizontally to find the x values and vertically, so up or down. If you're going horizontal to find the y value, then you're making errors. So the first point is negative 2 to positive 7. So negative 2, let's move up to positive 7. The next point is negative 1 to positive 1. So it's negative 1 to positive 1. Negative 1 on the x, and up or down, positive 1 is up, so we go up. The next point is 0 to negative 3. So 0 is right here on the x-axis, and we want negative 3 is not up, so negative 3 is down, so this is where negative 3 is. Next point, 1 to negative 5. So 1 on the x-axis and negative 5 on the y-axis. Next point, 2 to negative 5, 2 on the x-axis, negative 5 on the y-axis. So I want 2 on the x. Where do I find negative 5? Down. Next point, 3 on the x-axis, so negative 3 on the y-axis. 3 on the x-axis to negative 3 on the y, in line with negative 3. 4 on the x-axis to 1 on the y-axis. So 4 on the x-axis to 1, in line with 1 on the y-axis. And then 5, our final point coordinates are 5 on the x and 7. So 5 to positive 7. So So now we have all our points and our coordinates. We sketch our graph and we use our freehand to draw the parabola or the quadratic curve. We don't use any ruler. Try your best to get it as neat as possible. And this is our function f of x equal x squared minus 3x. And recall, because x was positive, the coefficient of x was positive, we have a minimum graph. Positive, so the legs will push towards the positive sign, hence the turning point will hang down. When the coefficient is negative, the legs will push toward the negative side of the y-axis, and the turning point will be a maximum. So when a, or the coefficient, is positive or greater than 0, we have a minimum graph. Or another way to remember it, the legs will push towards the positive side when a is positive. When a is negative or less than 0, the legs will put towards the negative side of the y-axis, and you have a maximum graph. But this is a minimum graph, and that's your parabola. Now, apart from graphing your parabola or your quadratic graph, questions can be asked from the graph. For example, determine the value of f of x when x equal 2. Determine the value of f of x when x equal 2. Remember that f of x is the same as y. So what this question is asking you, what is the value of y when x equal 2? When x equal 2, this is x. When x equal 2, this is it. So what we need now is to draw a line where x equal 2 to touch the graph. And in this case, when x equal 2, if we should draw a line to touch the graph, we wouldn't go this way, this direction, because the graph is not that direction. So we come this direction and it meets the graph here, and then we go horizontally and see which number on the y-axis it reaches. And in this instance, so when x equal to f of x, y is 5. Another question. Determine the value of f of x when x equal negative 1.5. Determine the value of f of x, the value of y when x is negative 1.5, 1.5. So in this case, we need to find where is negative 1.5 on the x-axis. So this is 1 right here. So 1.5 or 1.5 will be here. So all we need to know is a line to go and touch the graph from 1.5. And we draw a line here, and then we see where on the y-axis now. When you touch the graph here, which number on the y-axis is in line where you touch the graph? And in this case, the answer is 4, positive 4. So 1.5 is here, you draw a line to touch the graph, and then you see which number it coincides with on the y-axis, and the answer or the solution is 4 in this case for this question. Another question could be, determine the values of x for which f of x equals 0. Remember, f of x is the same as y. So they are saying that when y is 0, 0 is right here on the y. What are the values for x? So simple, use a paper or use a ruler. Where y is 0, if you should draw a line to touch the graph, the line will touch the graph here, and it will touch the graph here. So wherever you touch the graph here and here, when f of x, y is 0, those are the solutions, the answer. And in this case, the answer would be 3.8 and negative 0.2. 8. Again, the solution here would be positive 3.8 and negative 0.8. Because when y is 0, if you draw a line to touch the graph here and here, those are the two answers you will get. Another question they could ask from the graph: determine the minimum value of f of x, the function. The minimum value here of the function is the y value. The minimum value. So the minimum value is the y value of the turning point. The minimum value here. There are a number of ways you can find the minimum value. You can solve for the x first using a formula, and then plug in into the function and get it. Alright? But the minimum value will be the lowest point because it's a minimum graph. So the minimum value will be the y value here. So the minimum value will be the lowest point of the graph. Even though my graph isn't so perfect, so the minimum value here would be about negative 5.1. The minimum value is the y value they're asking for the turning point. So we're at the minimum here. This is at minimum, the lowest point of the graph. So the y value, which number on the y-axis will touch the turning point, and that's negative 5.2. And finally, another question that may ask: the equation of the axis of symmetry. Again, there's no one way to solve math, but the equation, a math with an equal sign, axis of symmetry you learned from earlier class, a line that separates something in two perfect halves. We could be smart and fold the graph and find the value. Fold it in perfect half, because parabolas and quadratic curves are symmetrical. Right? We can divide it in perfect half. But a formula to find the answer, which is sure, is x equal minus b over 2a. And you plug in the values. So x equal minus b over 2a. So from the question that was given, b was negative 3. So based on the function, we'd have minus, because it was already in the formula, minus 3 divided by 2 times a. What is a? For the function, a was 1. So you will end up with positive 3 over 2, which gives you 1.5. So x equal 1.5 would be the equation of the axis of symmetry. Thank you.